Hey friends, this is Coach Salinas, the math tutor again with you guys. Today we're going to be looking at how to use Desmos in the new digital SAT math portion. So we've got a sample problem today. We'll take a look at the problem. We'll try to set it up first, but Desmos is now built into the SAT test, in our digital SAT test. So I believe it's an important tool that we should be able to use and we should know how to use when taking this test. So let's take a look at this sample problem. This problem says a rancher budgets $5,500 to purchase bales of hay. So when we read that first sentence, okay, we should automatically think, okay, that's our budget. We're trying to stay within 5,500. So I'm thinking an inequality, okay, something my budget has to be less than or equal to 5,500. Okay. Now it also says the rancher needs to buy a minimum of 75 bales in order to maintain the discount pricing. So that's another inequality there. If a minimum basically means it could be that number or greater. So my inequality there would be greater than or equal to 75. And again, these are just notes that we kind of write as we're reading the problem. Um, so let's go ahead and read the next sentence. It says, if the rancher pays $35.50 for small bales of hay and $125.50 for large bales of hay, what is the maximum number of large bales of hay the rancher can purchase to keep the discounted price and stay within budget? So this problem is basically a systems of linear inequalities. It's a system because we're going to create two different inequalities. All right. And the nice thing about Desmos is it actually graphs linear inequalities for us if we can set up the inequality. So let's take a look at the two prices that they give us. Because this pricing is paid per bale of hay, whether it's a small one or a large one, we want to create our two variables here, the two things that we don't know. So one of our variables, let's call x. This could represent the number of small bales of hay. Okay. Now y, our other variable, we can let represent the large bales of hay. Okay, so, and I use X and Y because when we put it in Desmos, we want to use X and Y because our coordinate plane in Desmos is in X and Y's. So let's go ahead and create our inequalities here. So if our budget has to stay within 5,500, well, let's think about how we determine cost. If each small bale of hay is 35.50, we would have to multiply 35.50 times x. That would give me the amount that we would pay on the small bales of hay. Now we're also buying some large bales, so we're going to add how much we're going to pay in the large bales of hay, which the price for those are 125.15. So I'm going to multiply 125.50 times y. All right. So when I add these two costs with the small bales and the large bales, it has to stay within budget. So it has to be less than or equal to 5,500. Now, in order to get that discounted prices, I need to buy a minimum of 75 bales of hay altogether. So for this inequality, I don't have to multiply by price because all I really care about is how many bales I am buying. So if I was to add my small bales of hay plus my large bales of hay, it should be at least or greater than or equal to 75. So now that we've created our system of linear inequalities, now is where we can really use Desmos. So We go to our Desmos screens, and the nice thing about this is we could actually input these inequalities the way we see them. So we would type in 35.50x plus 125.50y. And we could also put the inequality here. If you click on the keyboard, this has to be less than or equal to 5,500. So, and you can kind of zoom on Desmos there. So this shaded region basically tells me the number of bales of hay, small and large, that I can buy and stay within budget. Okay, we really only want to look at numbers greater than 0. So if you were to look at here, okay, this point, I could actually buy 43 large bales of hay and stay within budget, all right, if I buy no small ones. Or I could buy all the way to 154 small bales of hay and stay within budget. But the question was, I want to find the maximum large amount bales of hay and stay within budget, but also still get the discounted price. So in order to get the discounted price, remember now, X plus Y had to be greater than or equal to 75. So we're going to put our greater than or equal to, we go 75. So now if you notice, we get another shaded region, okay? The purple shaded region here gives us our range, if you want to say, of what we can buy and get that discounted price. So now where this graph is shaded both green and purple, the intersection of both shadings, that is what would allow me to, one, stay within budget, but also get the discounted price. So within this shaded region, if I'm trying to figure out what is the highest or the largest amount of large bales of hay that I can buy, we would want to find the point here where where it has the highest Y value. Okay, so where would be that point of intersection there? The highest Y value is 31.5, but we cannot buy 31.5 large bales of hay. So we would um, get the lowest integer, okay, before that number, which would be 31. So the answer to our SAT sample problem would be 31 large bales of hay. So I hope you enjoyed this video. Okay, I hope you that were able to see how we can use Desmos in our new digital SAT to solve some of these problems, especially problems that deal with systems and systems of linear inequalities. So if you like the video, make sure you like it. Subscribe to my YouTube channel. We'll be trying to put up more sample problems where we use Desmos for people that are trying to study and prepare for the new digital SAT exam. Until next time, take care.